This video is about sine law and cosine law combined. 5a. A contractor is building a house. He first marks out 3 points of A, B, and C on the ground such that AB equals 5 meters, AC equals 7 meters, and the angle BAC equals 112 degrees. Find the length of BC. We'll label the length of BC as X. You are given side, angle, side. This angle is an included angle. Therefore, use cosine law. From a formula chart, we could say this is the formula given. So, these two is corresponding side and angle. Therefore, for this x squared equals, this will be the BC, and 5 squared plus 7 squared minus 2 times 5 times 7 cosine 112 degree. We put into graphing calculator, you will get this. Then you do square root both sides. You will get the x equals 10.0 meters. I will label here's 10.0 meters. Now let's go to 5b. He next marks a 4th point D on the ground at the distance of 6 meters from B, such that the angle BDC is 40 degrees. Find the size of angle DBC. We label as theta. For triangle DBC, you cannot get this theta directly. We already know this 6 meters and DC that's 10.0. This angle is not included angle, so you got to use this sine law. Since we didn't know this DC, we cannot get this theta directly. We label here's alpha. Then we do 6 over sine alpha equals 10.0 over sine 40 to figure out this alpha. Then you use 180 minus 40 minus alpha, you will get theta. So we have 6 over sine alpha equals 10.0 over sine 40 degree. Then you do cross multiply. Same line go to denominator, so sine alpha equals 10.0 as a denominator, 6 times the sine 40 degree. Then you do inverse sine to get this alpha. You will get this. Then the alpha equals inverse sine of this value. You will get 22.6855. Then theta equals 180 minus alpha minus 40. You will get 117 degree. Remember, if this is a middle value, don't change it into 3 significant figures. Just use the accurate answer as possible. Only the one we're looking for, like the size of angle DBC using 3 significant digits. Go to 5C. Find the area of a quadrilateral Abdc. Normally, for quadrilateral area, we need to divide this quadrilateral into triangles. Then we figure out the different type of triangle. We add them together to get the area of quadrilateral area. For this diagram, we already get the two triangles here, DBC and BAC. We got to use this formula, 1/2 AB sin C. For 1/2 AB sin C, remember this C is included angle, which means this is AB sin C. See, this is included angle. AB sin C, this is an included angle. Therefore, this area equals 1/2 times 6 times 10.0 sine 117 degree, then plus 1/2 times 5 times 7 sine 112 degree. Then we add this together will be the area of quadrilateral ABDC. 43.0 meters square. Let's go to 5D. The contractor digs up and removes the soil under the quadrilateral ABDC to a depth of 50 centimeters for the foundation of the house. Find the volume of the soil removed. Give your answer in meter cubed. Whenever you say this, give your answer in meter cubed. That means you need to pay more attention to the units. You need to change everything into meter. For example, a depth of 50 centimeter, you need to change into 0.5 meter. We're looking for this volume. You need to decide what kind of solid it is. When you dig up and remove the soil under the quadrilateral ABDC to a depth of 50 centimeters, it forms a prism. This will be the base area, quadrilateral ABDC. Therefore, your base area times the height. The height will be this depth. So we have volume equals this area 43.0 times 0.5. You will get the 21.5 meter cubed. Let's go to 5E. The contractor digs up and removes the soil under the quadrilateral ABDC to a depth of 50 centimeters for the foundation of the house. To transport the soil removed, the contractor uses cylinder drums with a diameter of 30 centimeters and a height of 40 centimeters. Find the volume of a drum. Give your answer in meter cubed. Before we get started, let's talk about the unit conversion. We know the 1 meter equals 100 centimeters. Then what about 1 meter square equals? How many centimeters square? 1 meter cubed equals how much centimeter cubed? Remember, when you do this square, you have to do this number square. So we do 100 square here. When you do cube here, you have to do 100 cubed. Normally, when you deal with unit conversion, you always check what kind of units are required. Before you do the multiplication, you have to change everything into this unit. Then it will make things easier. I will do the two ways so that you could see which way is clear and which way is easier to make a mistake. The method 1. Before you do the multiplication or before you working on this volume of a cylinder that given to you pi r square times height, you change this radius and height into meter first. Therefore, for this diameter, I will get 0.30 meters. So we have radius equal 0.15 meters. For this height, I will change into 0.40 meters. Then I plug into this formula. You will get 0.15 squared times 0.4. You will get 0.0283 meter cubed. Method 2. I just use the given units. Last step, you change into meter cubed. Therefore, for the volume equals, the radius will be 15 meters. Therefore, pi times 15 square times 40. You will get this big number, centimeter cubed. Then you need to change into meter cubed. You have to divide it by 100 to the third power. This step, a lot of students will make a mistake. Then you will get the 0.0283 meter cubed. Normally, we use this method 1. Let's go to second one from 5E. Find the minimum number of drums required to transport the soil removed. The number of drums we can get by doing 21.5 meter cubed over 0.0283. You will get, since the minimum number of drums has to be integers, natural number, therefore you will get 760. This will be the answer. We call this kind of problem is a round up problem. Even you get here, it's a 759.1173. For example, you still get 760. You have to round up. No matter what this number it is. So when you see these words, minimum number of something, and it's integers, then you need to pay more attention to say whether it's a round up problems, such as when you're looking for minimum number of cans of paint. Normally, it's always a round up problem. Let's go to 7a. A surveyor has to calculate the area of a triangular piece of land DCE. The length of CE and DE cannot be directly measured because they go through a swap. AB, DE, BD, and AE are straight paths. Path AE and DB intersect at point C. The length of AB is 15, and BC, that is 10. AC is 12 kilometers, and DC is 9 kilometers. The following diagram shows the surveyor's information. Find the size of angle ACB. So we put this as a theta. Since you are given 3 sides, then look for the angle. We got to use the cosine law. For cosine law, remember A and this cosine A, they are corresponding sides and angle. So we have cosine theta equals. This will be the corresponding size and angle. So we have 12 square plus 10 square minus 15 square over 2 times 12 times 10. So we put into graphing calculator, you will get 19 over 240. Then this is theta. We do the inverse of 19 over 240. You will get the 85.5 degree. For second one, show that the size of angle DCE is 85.5 degree, correct to 1 decimal places. According to this diagram, you could say angle ACB equals angle DCE because they are vertical angles. Vertical angles are equals to each other. Therefore, we could say DCE equals this ACB will be equals to 85.5 degree. Now let's go to 7b. They measure the size of angle CDE to be twice that the angle DEC. Use angle DEC equals 85.5. Find the size of angle DEC. DEC, let's label this is a theta. So that CDE will be 2 theta. Or you can do the 2x. It's really up to you. We know that the sum of all angles in a triangle equals 180. Therefore, we can do 85.5 plus theta plus 2 theta equals 180 degree. Then 3 theta equals 180 degree minus 85.5. Then theta equals, both sides we divided by 3. You will get 31.5 degree. And for 2 theta will be 63 degree. For second one from 7b, find the length of DE. For DE, since you are given 2 angles already, we can use the sine law. So we have DE, let's label as x. X over sine 85.5 degree equals 9 over sine 31.5 degree. So cross multiply. The same line with this x go to denominator. Sine 31.5 go to denominator. Then 9 times sine 85.5 degree, you will get 17.2 kilometers. Let's label that is 72.2 kilometers here. And for 7c, find the area of triangle DEC. Using this formula, remember we need included angle. So we have these two sides, and then angle will be sine 63 degree. Therefore, for this area equals 1/2 times 17.2 kilometers times 9 kilometers times sine 63 degree. We put into graphing calculator, you will get 69.0 kilometer square.